Hey YouTube, here's my video on how to get up and running with my METARMap installation. I apologize, I'm not a YouTuber, I'm not a content creator, so I'm figuring this out on the fly here as we go. If you have any comments or suggestions or things I'm missing, please drop a comment down below so I can hopefully update this video and make it as dead simple as possible for just about anyone to get up and running with this project. I had a lot of fun coming up with this project and learned a lot about coding and AI and all sorts of fun stuff through the process. So that's what makes this project fun for me and helping other people getting up and running and creating their own maps. Like I said, someone with zero knowledge of how to do this should be able to get up and running with this project. So here we go. If you head over to raspberrypi.com, this is where we're going to download our software for the imager. Software. Scroll down here and download for Windows or Mac or whatever you're using. Download and install it. And go ahead and open it up. We'll have this right here. Depending upon what device you're using, a Pi 02W works really well for this. I'm using a Raspberry Pi 4 as my test machine that I bring with me on the road here. So I'm going to choose that. For the OS, I'm going to choose Other. I like this to be as lightweight as possible, especially if you're using a 02W or a Pi 0. We're going to choose Other and then our Raspberry Pi OS Lite 32-bit right here. For our storage, you should have inserted your micro SD card. 16 gigs will probably work just fine. I've got a 32 gig card here, so I'm going to select that. And this will erase everything on the card, so make sure it's a card that either has nothing on it or nothing that you care about. We like to apply custom settings. We're going to say yes, edit settings. I'm going to leave the Pi host name. This is what your wireless router is going to look for. This is how your Pi is going to show up on your wireless router. I'm going to leave that as Pi, and then our username Pi. Leave this as Pi. All of my commands and everything assume that the username is Pi. So for ease of use, go ahead and leave that like that. I'm just going to use password as my password. If you want to be more secure, go for it. This is just sitting on your local network. There's no personal information or anything on this device, so be as secure as you want to be. The SSID I use on the road here through my laptop is Aviator, and my simple password here. Choose your country. I'm in the United States. I live in Denver, so we're going to hit, before we save, going to go over to services, make sure enable SSH is checked, and then use password authentication. That's going to use this password here, so we can get into the Raspberry Pi through SSH, which is a command line style interface. Options here, I just have it eject the SD card. Actually, I'm going to uncheck that, so that way our SD card stays connected to the computer, and we're going to copy over a file before we eject it. So we're going to hit save. Would you like to apply these settings? Yes. All existing data is going to be erased. You want to continue? Yes. So this is what this is the first time you're running this. You might get these errors because it is formatting the SD card, and Windows doesn't quite know how to handle that. It's going to download the OS, and then it's going to write it to the SD card. While that's happening, let's go download Putty. This is a simple SSH client. I've already downloaded it and installed it, so just Google Putty like I did. Sorry, I probably moved kind of fast. Just Google Putty, putty.org, and then the download link here. I'll leave a link in the description that'll take you straight to this site. And then, yeah, based on what your operating system is, 64-bit Windows is probably going to be this first installer right here, so go ahead and click on that. Go ahead and download it. I already have it installed here, so when you open it up, it's going to look like this. We're going to need to get our IP address, local IP address from the Pi once it connects to our Wi-Fi. Back here, when we were setting this up, make sure you put in your Wi-Fi credentials, obviously, your SSID, your password for your Wi-Fi. And then, so we're going to, how we connect to the Pi then is going to be Pi, the @ symbol, and then the local IP address of the Raspberry Pi. It's every Wi-Fi router is a little bit different. So you're gonna have to just go into your Wi-Fi router settings, or you should be able to connect via pi.local. Sometimes that works for me, sometimes it doesn't. So I like to just find the IP address, and then we'll connect over port 22, and we'll make sure our connection type is SSH. While this is still, so this will write the SD card and then verify it. The other thing we need to do real quick is go to github.com and then my repository and my project, my METARMap project here. I'll leave a link, of course, to this. We're going to need the setup.sh file. So let's click on that. And whether you are in the main branch or the production branch, both should work. I suggest using production. The main branch is kind of my beta. This is my nightly build. It can be unstable and cannot work. So let's go to production here. This is the stable version of everything I have up and running. We're going to come over here and click on download raw file. It's going to ask us where we want to download this. It should just be setup.sh right here. We're going to save that. And let's see where we're at here. We're almost done verifying. So I've simplified the process here. What this script does is walk you through installing everything that needs to be installed onto the Pi for this project. I spent a lot of time creating a settings interface for this project, so pretty much anybody can get this up and running. You don't have to worry about doing too much actual writing of code or command lines or anything like that. As you can see, we are now finished. We can eject the SD card if we want to. I'm just going to hit continue and close this. We're done with that. I'm going to open up our downloads folder here. We have setup.sh right here. And I'm going to open another folder. This PC, we should have. Oh, it looked like it did eject the SD card, so I'm just going to unplug it and plug it back in. Of course, this is being a little wonky for me. There it is. Okay, so that was it. My bad. We're just going to copy over the setup.sh file over here. That way we can access it on the Raspberry Pi without having to do too many crazy things. So let's go ahead and plug in our SD card into the Pi and boot it. So when you insert your SD card and boot your Raspberry Pi for the first time, it can take 5, 10 or more minutes for it to show up on your Wi-Fi network. The Raspberry Pi is doing a whole bunch of stuff on first boot, uncompressing a whole bunch of stuff and getting everything set up and then connecting to your Wi-Fi network. So definitely give it a solid 10 plus minutes, and then go onto your Wi-Fi router and find the device just called Pi. There should be a local IP address. It should look something like this. So we're gonna plug in here Pi @ and then the local IP address. We're gonna hit open. You might get a warning here that the host key is not cached on the server, blah, blah. This is just the key, how your computer is going to talk to the Pi. We're going to hit accept. And it's going to ask you for a password. So I'm going to throw in my password, which is password. And as you saw there, nothing showed up in the password field as I typed. That's normal. And now we're in. So Pi @ Pi, this is us in essentially the root folder. If we type ls, this is unnecessary, but that would list any files that are in this folder. And as you can see, there's no files yet. We need to move that setup.sh file from where we put it in the root directory of the SD card over into this folder here. So let's go ahead and do that now. Okay, so that setup.sh file that we just dragged onto the Raspberry Pi SD card is located in this boot firmware folder. So this command sudo cp secure copy. Sorry, let me start over. Sudo, this is just saying we're the super user, we're in charge. We want to copy this file here that's located in this folder over to our home Pi folder. So let's put that command in. Anytime you want to paste a command into this Putty terminal window here, simply right click or go copy the command and then come in here and just simply right click anywhere in this black space and it will paste that in there. So let's hit enter. Now if we do ls again, that'll list our files. Now we have that setup.sh file right here. So the next command we need to run is sudo bash setup.sh. So sudo, again, we're in charge because this setup.sh file is going to install some stuff and update, so we need super user permissions. Bash is just the program we're using to run this setup.sh file. So let's hit enter. Welcome to METAR Setup. Would you like to update the system? So anytime it's going to ask us a yes or no question or ask us to input anything, if one of the responses is capitalized, like in this case the Y, that is the default response. So if I just hit enter without typing anything in, it will assume Y for yes in this case. So let's hit enter without typing anything in. I've actually already run this on this Raspberry Pi, so this is probably going to happen pretty quick. If you're doing this for the first time, this is probably going to take maybe 5 or 10 minutes. So go ahead and pause the video here, let this run successfully, and when you get to this next virtual environment command, go ahead and come back to the video. So after your system has been updated successfully, it's going to now ask you for a virtual environment. We want to say yes because we have to create this virtual environment for installing some of these packages. So again, Y is assumed. I'm just going to hit enter. And now it's going to ask us to name it. The default is METAR, so I'm actually going to type nothing in. I'm just going to hit enter. And if you want to change the name of this virtual environment, go for it. But all of my commands that are going to be installed later assume that your virtual environment is called METAR. So it probably behooves you just to leave it as default. Now it's going to ask us if we want to install some packages. The following packages will be installed: Adafruit, CircuitPython, NeoPixel. This is what controls the LEDs. Flask, this is our web interface for our settings website. Requests for some API stuff, and schedule, so we can schedule some tests. Again, yes is assumed. I'm just going to hit enter. That's going to go through and install all this stuff. Again, I already did this on this Pi, so this is going to happen fairly quickly. It might take a little bit longer for you, so if you need to pause while this runs on your Pi and then come back, feel free to do so. I'm just going to let this run in real time. It shouldn't take too long. There we have successfully installed the NeoPixel library, so that controls our lights. It's installed Flask, requests, and then schedule. All packages successfully installed. Would you like to install an auto Wi-Fi broadcasting capabilities? I suggest you do this if you're not a power user, if you're new to Raspberry Pi. This makes life really easy. If your Raspberry Pi drops off your Wi-Fi network for whatever reason, let's say you go and change your Wi-Fi password for some reason, this is a little program that runs in the background, and it looks to see if it's connected to Wi-Fi. If the Raspberry Pi is not connected to any Wi-Fi, it will broadcast its own Wi-Fi network that you can then, hop on your laptop just like this, connect to that network, and then go through a process to reconnect it to your Wi-Fi. Or if you're building this map at home and you're going to take it to, your shop or something that has a different Wi-Fi network, when you plug it in that unknown location, this will then broadcast its own Wi-Fi network. You can connect to it, and then I'll show you how we can connect it to a new Wi-Fi network. That's all built into my program. So let's hit enter for yes. And this will launch its own interactive installer. This is a program that's actually written by somebody else that I use. So do you want to proceed? There's no default here, so you're going to have to say yes. And then this is just kind of outline some of the defaults that we're going to change here in just a second. So ready to proceed, yes. It's going and fetching everything we need. So the first thing we need to do up here, option 1, is actually install this access pop-up script. So type in 1, enter. It's going to run through this real quick. Okay, it's done everything it needs to. Press any key to continue. It's going to take us back here. So now we're going to actually change the SSID. So type in number 2 and then enter. I like to call it METAR Pi. You call this whatever you want. I suggest something without any spaces. The Wi-Fi system just tends to work a little nicer that way. So that's going to be our SSID now. Now it's going to ask for a password. I'm just going to type in password as the password. Again, if you want to be more secure, go for it. And here's just a nice little overview. You've changed the SSID, new password, any key to continue. Now we're going to change the IP address. I'm going to type in number 3, which is this option here. And it's going to ask us what kind of scheme we want to use. I like the 192.168 scheme, which is how we're connected to this Pi. So I'm going to type in 1. And now this is for the third set of numbers, so 192.168 dot what? I like 8. That's just what I've been using. And then this is the fourth set of numbers, so 192.168 dot what? I'm going to use 1. Here's our new the new IP address that the Raspberry Pi will use when it's using this program specifically. So I'll show you how that works here in just a minute. Press any key to continue. That's pretty much anything, all the things I do with this program. You can force it into access pop-up mode if you want. You can change your host name, which I don't suggest doing. You can uninstall it, or we can just simply exit since we've done everything we need to do. So 9. This will launch us back into our setup script. Service installation. Services on the Raspberry Pi are kind of like elevated programs. They run at the system level. And so that's how I run my METAR script that runs the lights. Everything seems to work a little better when it runs as a service. So it's going to install a METAR service, a weather service, that's what fetches our weather, setting service, and a scheduling service for turning the lights on and off, dimming them, stuff like that. So would you like to install the services? Again, the default is yes, so enter. It created those services, and now it's going to activate them. There we go. All of our services are in there and enabled. Aliases. I do a lot of tinkering, so instead of writing out these big long commands, I have aliases which shorten these commands down. You'll probably never use them. I have the default set as Y just in case you ever do want to use them. I'm going to use some of these aliases here in just a minute to kind of show you how you can troubleshoot some stuff on your own if you want to. So I'm just going to say yes to install those aliases. All it does is create some a file with a whole bunch of aliases in it. Tailscale, this is like a VPN, so you can remote into the Raspberry Pi. I have this set as no. A lot of people probably don't need this because this is probably just running on your local network. If you are going to set this up and then say take it to the hangar, take it to your shop, whatever, and it's going to be remote. If you want to say yes to this, I'll tell you what, we'll just run through this and see what happens. Otherwise, you can skip forward in the video. This is a dead simple VPN to be able to connect to this thing anywhere. So I'm going to say yes. It's going to pull down some files and install Tailscale for us. And like I said, Tailscale is like a dead simple VPN that makes it look like some of these remote devices are on your local network. So let's go ahead and we'll let this run here. Shouldn't take too long. It's usually pretty quick. This is doing like what we did at the beginning. It's looking for any scripts that need to be updated, or excuse me, programs that need to be updated. And now it is actually getting this package here, the Tailscale stuff for us. It's only about 26 megabytes. It's almost done. Okay, so part of this process, if you go to tailscale.com, create yourself an account. I just log in using my Google account. What this is going to do now is start the setup process. We hit enter. It's going to give us a URL so I can actually add this to my Tailscale network. So I'm going to copy this. So if you just highlight this, and as soon as you let go of the mouse button, it's copied to your clipboard. Don't worry, I'm going to delete this as soon as this video airs, so this won't actually exist here in a second. But go ahead and take this and put it in your web browser. So I pasted that command and I've logged in to my Tailscale account. You'll be presented with this. Just hit connect. And successful. That has now been added to your network. If you go to, you view the console here. This is all my machines and all of my, everything I've connected to my tailnet, as they call it. So I'm going to go down here and find the device. Here it is that we've just connected here. A couple of things you want to do. You can see that SSH has already been enabled. That's part of the script that we just ran. Probably what you want to do is click on this and say disable key expiry. After, I think it's 90 days, the keys expire for these. You have to come in and update it. If you just click that, it's a much easier way to not have to deal with that. And then if you want to edit the machine name, you can do that here as well. So just turn that off, and I'm just going to say, I don't know, METAR Pi default. As you can see, when I try to put a space in, it actually put a hyphen in here because they don't allow spaces. So anytime you go hit the space bar, it's going to enter a hyphen and just update name. I'll show you how we can then use this to remote into the Pi later on. Let's see if I can go find it here. I lost it. There it is. So it's given it an IP address, which again, I'm going to delete this. And the default, yeah, we'll just use this IP address for everything. And we'll come back and take a look at that in a little bit. Okay, so we've added the device to the tailnet, and now we need to actually go and get the files that are going to run the map project for us. So the easiest way to do that, in order to use the update function of the settings website and everything else, we have to install Git. So Y is assumed. I'm just going to hit enter. This is going to go install this is going to install Git for us, which goes to our repository here and allows for like file versioning and things like that, so it can know what version you're on versus what version I've uploaded to the repository here, and it can then update the system. So now it's going to ask us what branch. As I said before, the main branch is kind of the development, and beta branch. Production is the stable branch. So we're going to type in number 2 here because we want the stable version and hit enter. It's going to go pull down a whole bunch of files for us. And there we go. All the files are now on the Raspberry Pi. Since we did install Tailscale, in order to remote into the settings website, we are going to need an SSL certificate. If you're just going to host this on your home Wi-Fi network, I would just say no here, which is the default response, and not worry about it. For me to show you how the Tailscale thing works, I'm going to actually say yes. This is just a self-signed certificate. You pretty much are creating yourself a security certificate, and it's going to walk you through that process. So it's going to ask us a couple of questions here. It's creating the certificate. It's going to ask us for our country code. I'll type in US, state. I'm just going to put a period in because it doesn't matter. Locality name, I'm just going to hit period again. Organization, don't want to give you that. For all these, I'm just going to put a period. Common name. So this is the actual local IP address of your Raspberry Pi. So I'm going to say 192.168. What was it here? Just a minute. I gotta go get that. I'll be right back. Okay, I forgot what it was. 137.65. Email address again. Don't want to give you that information because it doesn't actually matter because it's just a self-signed certificate. We do actually, it is important to put in the local IP address. So if you're going to move this to somewhere else, we can go find the local IP address again, and you can run through this script. just say no to everything until we get to the SSL certificate, recreate the certificate, and then just put in whatever the new local IP address is there. Would you like to reboot your device? At this point, the setup's complete. I'm just going to say yes. You're going to get this error because the Pi is dropped off our network and the connection is no longer open. So I'm going to let the Pi reboot, and then we'll come back and continue. So after the Pi reboots, you can come up here and right-click and just say there should be a restart session option right here, and it should prompt you for the password again, and you should be able to come right in back into the Pi here. Enter our local IP address here, 137.65. We do need the HTTPS since we enabled the SSL certificate. You're going to get this connection not private. Since it's a self-signed SSL certificate, web browsers don't really like it, but it'll work for what we're doing here. So we're going to hit Advanced, Proceed, and you should be presented with this website. This is what's being run on the Raspberry Pi, and we can set up pretty much everything from here. I'm going to run through this real quick if you're not interested in me going through step by step every single one of these settings. There is a little tooltip here for each, for everything that you can do some little self-education on. I'm going to run through them. If you want to, go ahead and skip forward. Default brightness is the brightness of the LEDs when dimming is not enabled. We'll talk about that here in a second. Again, I use 50%, seems plenty bright. Nighttime brightness, if you enable nighttime dimming later on, we'll talk about that. This is the default brightness for that time period, 0.3, 30%, usually works pretty well. Windy dim brightness, so the windy animation, the LEDs go from whatever the default brightness is based on the time of day, and will dim down to this brightness here, 0.05 works pretty well, and then they'll fade back up to their default brightness here. Animation settings, we can turn these on and off down below. Animation pause time, this is the time between animations. So if you just have, say, the windy animation turned on, any airports that are windy, every 15 seconds they will fade and then come back. And it runs through that animation cycle in this time period. 15 seconds works pretty well. If that's too distracting, up it to, say, 30 seconds. Wind threshold, any value that a weather that an airport is reporting over this value, so 21 knots or more, will then trigger that airport to be windy and trigger the windy animation every 15 seconds. Fade time, this is how long it takes the LED to actually go from its default brightness down to the dim brightness. The wind fade time, yes, okay. So the amount of time it takes to go from this brightness to this brightness. The fade pause time is how long it stays at this dim brightness before it returns back here. So if you have a big map with a lot of lights, a longer time period here allows you to actually see the animation happen. All the lights will dim over half a second that are windy. They will then stay dim for a second and a half. So if you have a large map, if you up this to 2 or 3 seconds, you can actually then scan your entire map to see which lights are dim before they return back to their default brightness over half a second. Again, just play with these, see what works best for you. These are just my default values that tend to work pretty well. If you have the lightning animation enabled, this is how many times the LED will flash whatever color you set for lightning down here. It flashes extremely quickly. White works pretty well because lightning happens to be white. Snow blink count, again, if the METAR is reporting snow, is how many times it will slow blink your snowy color, which it looks like I didn't add that to the production branch here. I'll add that here in a second, and you'll have just another color picker for what you want your snow color to be. And that's a slower blink. It'll turn whatever color you set and then blink however fast you want to blink. VFR, this looks like a pretty lime green right here, but if you click on this, you'll see it's purely green. The LEDs show a much better green than this. So green, blue for marginal, red for IFR, pink for low IFR. Excuse me. The lightning color, I usually keep it at white, and then missing. So if the station is not reporting a flight category, whether it's one of these 4 flight categories, it will use this color to let you know, hey, this station is not reporting a flight category currently. Let's see as we go on here. These are more advanced settings here. So number of windy step animation steps. This has to do with the math that the Pi does to fade the LED, how many different iterations of brightness the LED goes through between your, let's say it's at the default brightness of 0.5, and it's going to go through 100 different brightnesses to get down here to 0.05. Leaving this at 100 works pretty well. It's a happy medium between a nice looking fade and having the Pi do too much math. So I would suggest leaving that at 100. Pixel count, this is how many LEDs are in your strand. It is probably going to be this number here. So in the default file I included with the airport file, there are 25 LEDs here to get all the way out to Fort Morgan. We'll talk about that here in just a second. So I could change this down to 25 if I wanted to. Anything shorter than that, and the LEDs won't light up because the program's going to go through, let's say if I set this at 24, the program's going to fetch weather for 25 airports and try to display 25, but there's only 24 LEDs, so it's going to crash. We'll leave this set at 25 because that's how many airports we have down there. Pixel pin. This is the GPIO pin number for the data line that's going to your lights. So when we plug our lights in, I use GPIO pin 18. It's not physical pin 18. It's just the it's the GPIO pin 18 as the Pi knows it to be. So just whatever the GPIO number is for that pin, if you're using 12, just put in 12. We're using 18, so I'll leave it there. So these are our toggles for our different settings. Enable lights on off time. Down here, you can set what time the lights come on and what time the lights turn off. If this is in your house and say at 10 o'clock, the lights will on the map will turn off. They'll come back on at 7 o'clock. If you want to enable that feature, simply have that enabled. Daytime dimming. So as it gets darker outside in the evening, the bright time start, say in the morning, will be 7 o'clock here. So they'll go from that 0.3 at 7 o'clock, they'll go to 0.5 brightness. And then the same thing is, the opposite is true in the evening. They'll go from this 0.5 down to the 0.3 at whatever the dim time start is here. So in this case, 5 p.m. And that's this toggle here to enable or disable that. If you want the LEDs just to stay the bright default brightness, just disable that. If you want to enable or disable the windy animation, the lightning animation, the snowy animation, you can turn all those on or off here. The LED legend. I'll have some more documentation up on this. I haven't quite finished it yet, but what this does is goes to the end of your LED strand and then counts backwards and displays LEDs, each one of these colors. So in this case, I have 25 airports here. So let's say I added another 10 LEDs to the end of this strand. So I'd have 35 LEDs. I'd have to change this to 35 so the legend knows where to start. So it'll start at LED number 35 and it'll light LED 35 up VFR, and then working backwards, it'll light up number 34 marginal, number 33 IFR, and so on. So you can have a little legend off to the side of your map. So if people don't know what all these different colors are, they can come in and see a legend on the side of your map. Be like, oh, green means visual flight rules. Just kind of one extra little feature, I suppose. And then enable HTTPS. Since we installed an SSL certificate in order to access this via Tailscale. We have to have this enabled. If we disable this, we won't be able to access this anymore because it's going to look for that SSL certificate. Again, all of our times down here, just simple time pickers for when you want things to happen. Again, tooltips for everything. If you want your airport file, okay, this is probably what's going to take you a little bit of time to fill out. You have to go through and count all of your LEDs. So the LED that's closest to the Raspberry Pi is LED number 1. As you can see, I did not want that LED to light up. Skip just means, hey, there's space between an LED that's an actual airport, and skip is an LED that you don't want to light up. You want the program just to ignore it because you're running from one airport over to another one. So my first LED is blank. My second LED is Centennial Airport, and then in order for me to stretch the strand over to Buckley Air Force Base, I actually had to have another blank LED. So it's probably going to take you a little bit of time. Go through and count your LEDs, which airport is which. I just write on the back of the map which airport is which, and then come through here and just type them all in and just use all caps. So each airport or skip should be on its own line. So if I were to add, another airport down here, I could hit enter and then say, JFK or whatever airport I wanted it to be. Each airport should be on its own line. Wi-Fi settings. So let's say you installed that Wi-Fi broadcast program that we set up earlier. You took this Raspberry Pi off to your shop. You turned it on. You come look at, you connect to it using the password that we set up down here. You would then go to HTTPS, since we did the SSL certificate, 192.168.8.1, because that's how we set it up in the program earlier. You will then be presented with this site. So you can come here and then hit scan for networks. The Raspberry Pi is going to go look for nearby networks. Scan's complete. And since I'm in a hotel, there's all sorts of crazy stuff around here. This is the Wi-Fi I'm using off my laptop, what we're currently connected to. You just go click on the network you wanted to connect to, enter the password for it, hit connect. Of course, your connection would then be interrupted, and you would then have to go onto the new Wi-Fi router, find what its IP address is, and connect to it that way. However, since we have Tailscale installed, this device will now be connected to your tailnet. So another way to do that is go get your IP address for this device like we saw earlier in the Tailscale website. And again, just type in your HTTPS and then your Tailscale IP, which in this case for me is this. So HTTPS and then the IP address of your the Tailscale IP address. Hit enter. Oh, you know what I forgot to do is actually open Tailscale on my laptop, because I am not connected to my tailnet. My Raspberry Pi is, but I am not. So I've opened Tailscale down here. It says I'm connected. Let's try this again. There we go. We get the same privacy error because we created this SSL certificate. The web browser's like, this is kind of weird, but since we created it, we know it's safe. We'll proceed. And here we are. So I'm connected through the internet to the Raspberry Pi that's sitting right next to me on my desk. So you don't have to go find the IP address, the local IP address anymore. You can just use the Tailscale. All right, so that's connecting to a Wi-Fi network, a really handy feature if it ever drops offline or you're moving it to a remote location that you don't know the credentials do. You can enter it here. So since we did make some changes up above, I'm going to click Save. We get a little notification here. Hey, everything's saved successfully. I'm going to restart the METAR service, which is going to wake the LEDs up and apply all the changes we just did. This restart settings service, that's what's running this website. So if we update, if we come down here and we check for updates, this is going to the GitHub repository and actually looking at all of these files here to see if anything's changed. If anything has changed, you'll get a little button that says, hey, update available. You click update, and all of this we'll then have to go restart the METAR service again, and then we'll have to restart the settings service. Pretty much what this does is on the Pi, kills the website hosting server and then restarts it. That's what that little timeout is for, and then you just simply refresh the page and the settings will be applied. You can force update the weather here for all your airports. So you can see the last update happened at 9:15 a.m. or excuse me, 9:14. If I update the weather here, you can see there's our new updated weather. The one toggle that I don't have on this production branch that I'll have added here in just a minute is an update weather function that you can put in, however many minutes you want the Pi to go fetch your weather update. I apologize, that's not in here. It's a pretty straightforward setting. But then I suggest every 5 minutes. It's a happy medium between, pinging the server too often and having live up-to-date weather. And then this should reflect that every 5 minutes. Check for updates. Like I said, when you click this, it goes and looks at my GitHub repository to see if I've updated anything. With a production branch, it's definitely slower to be updated to make sure everything's stable and working correctly for those updates. And then stop METAR. This will kill the METAR service in the background that runs the lights and also turn the lights off. So if for some reason you just need to kill it, you can do it manually here. And I'll also have tooltips here for all these buttons as well. So after clicking stop METAR, if you want the lights to come back on, hit restart METAR service and they should light up. And that's pretty much it. If you want to get more into the nitty-gritty and see how some of this stuff works in the background, we can dive into that here. But other than that, you should be all set up and good to go. For some of our services that are running here, like I said, those aliases and everything else that we set up, it shortens down some of the commands that we have to type in. So if I want to check on the actual METAR service, I can type in METAR status, all one word, hit enter, and it's going to tell me, hey, it's loaded, it's enabled, and it's currently running. Excuse me. We can do the same thing for the settings service, so settings status. And this is what's running this website here. Everything's up and running correctly. Anytime this one didn't actually auto close for us. If you hit Control C, that should back you out of that command. And now we have our cursor here ready to go. If for some reason something's not acting up right, you have, let's say this had failed for some reason. You can run simple commands like, and these are all aliases that I've added. So on a normal Raspberry Pi, these won't work. Since we loaded these aliases, they will. I'm going to say stop settings. Now if we come here and refresh our page, we've killed this service. So if you push up on the arrow keys, you can go through your previous commands, setting status. You can see it is dead. Control C again. And so let's start settings and refresh the page, and there it is. So start, stop, and restart, and then the name of the service are all built into the aliases that I've included. So same thing with METAR. We can say stop METAR, METAR status. You see it's dead here. Control C to back out of that. The lights are still on at this point, so I've also included a script that will turn the lights off. We'll just simply type in blank. That'll turn the lights off. So if you're in the command line, you need to turn the lights off. That's all it takes. Excuse me again. Now, instead of just simply starting and stopping a service, that's something that runs in the background. You don't really get any command line output, so it's hard to troubleshoot. So if for some reason you type in, say, start METAR, the lights don't come on, something's not working right. We can do a little more troubleshooting here where we get a little more output. We can type in METAR, METAR.py, metar.py is the actual file that we're running. Metar is an alias that includes a whole bunch of commands inside of it that allows us to run this command, or excuse me, to run this file. And you get a little more output here. Daytime dimming is on and enabled. The current brightness is set to 0.5 because we're outside of our daytime dimming. We're outside of this window here. Or excuse me, we're inside the window for to use the bright setting. And then here are all my airports. Here are the flight category they're reporting. The current wind speed, the wind gusts, if the software considers it windy, if there's lightning or it's snowy, and then the brightness that it's using for that LED. Just kind of some troubleshooting stuff. So right now you can see everything is under our 20 knot threshold that we set up here. So if we reset this to say 8 knots, because I believe there's an airport, yeah, the spaceport is showing 10 knots. So if we change this to 8, we come down here and hit save. And then we hit Control C to end this command, push up on the arrow key to get that command back. It looks like my lights came back on. I'm going to stop them again. And then do this. So now, since our threshold is 8 knots, you can see CFO is now considered windy. And every 15 seconds, this LED, which is LED number 6, should fade and then come back bright. That's just, again, some simple troubleshooting stuff you can do with some of these other commands. The same is true, so I'm going to stop the settings service. Anytime you want to run something manually, like up here we ran metar.py, we're going to run metar settings.py, and this is going to run our the website kind of in the foreground here. So if I come over here and refresh this page, you can see the different requests were sent and everything was loaded. If we hit, say, restart metar service, you can see that restart metar service was triggered and then everything else is reloaded. So again, just kind of a better way to troubleshoot. If something failed, you'll get a failure message here, kind of telling you what happened, and we can troubleshoot from there. So I'm going to stop this and I'm just going to start settings so it's running in the background. So that way if we refresh here, it's still running. That's pretty much it. Play around with this stuff, have some fun. If you want to get more into the Raspberry Pi stuff of it, we didn't do this earlier, but if I hit ls again, here are all of the files that we downloaded and that's running this entire program. So if you actually want to see what's going on in here, we can do sudo nano, which is like a text editor. Let's do config.py. This is what holds all of our configuration settings. Excuse me. So our airport file is called airports.txt. That's something that I've just set up. That's really neither here nor there. Pixel pin. That's a setting we can change here in our website here under the advanced settings. See, that's our pixel pin here. And then pretty much everything else, the number of pixels we've set inside the website. So if you don't want to use the website, you can come in here, use your arrow keys, navigate around. Say, let's say our default brightness is, let's move it to 7. Oops, I tried to use my number pad and it doesn't like that. So let's use number 7. In order to save this, we're going to hit Control X. It's going to ask you, do you want to save the modified to the buffer? We're going to say Y for yes and then enter. And then since we save that file, we need to reload it. So we'll go over here and we will restart the metar service and restart setting services. Sorry if this looks a little different. I just updated this off screen real quick. But after you update or change anything using sudo nano config.py, for example, anytime you save anything in a file like this, and you hit Control X, Y to save it, and then enter, you'll need to come back over in here and either restart the metar service, restart your setting services, or you can do that from here, say restart. Oh, this is lagging on me because I have a bad connection. Restart METAR. So that'll do the same thing, or restart settings. Yeah, I hope you enjoyed it. Definitely leave me any comments, suggestions in the comments down below, and enjoy.